Alright, time for another draftphysics.com, debatephysics.com also, but debate is prohibited, essentially. Can't have one. Can't argue the arguments. Especially at Shittopedia. Okay, just can't even bring up the subject that they might be a little too arrogant in what they're stating. Maybe they're stating it a little bit incorrectly. Maybe they got something wrong. They won't hear it. Won't let you say it. Block you for life because you dare to argue their physics. They will tell us what the truth is, and we must believe. Or you're an infidel. I mean, it really is that bad. And it's very sad. Okay, that's the world we live in. Very creepy and underperforming, frankly, in so many ways, and mostly because of this obnoxious groupthink arrogance that everybody has to live under the authority of. You have to be one of them. All right, anyway, so photons. So no point in reading their gibberish until I give you a better answer. Okay, a lot simpler. You know, photons, there's lots of things we figured out because you do certain little experiments, you get a certain little outcome. And, they talk a lot about the two-slit, and I've already gone over that one a million times, and it's perfectly explainable as a particle theory. The big one is Einstein showing up to, do the opposite of what he did in the case of gravity. That is, he makes sense when he talks about photons, and he makes no sense at all when he obviously is talking about the wooey force of gravity. But so there's some things you can detect, and so one of the things, the key events in physics is sort of this idea that electrons can leave a surface. They can be ejected from a surface, or you can cause electricity, all right, to move through a substance by hitting it with light quanta. All right, and the idea is that it took a certain amount of energy, as they put it, to cause electrons to move, and the more energy you put in, the faster they would leave. Okay, so the more energy they could have. So you give them a little bit of energy to leave, or a lot of energy, cause a lot of electricity, a little electricity. And this became associated with the frequency of the photon. And so the word itself, photon, says that this is some sort of, that there's something in space called a photon. And photons are really an event. So that's sort of what this experiment is explaining to you, is that it's an event. It takes a certain minimum energy, right? So it won't work with any photon. It only works with certain photons. And the trick is this idea of frequency. So I've made this argument numerous times. If I had a pole that I was going to try to tip over that wobbles, okay, and I can hit it with something and I can cause it to wobble back and forth. And the trick is if I add the energy at the right interval, I'll easily knock it over. But if I add the energy at the wrong interval, that is when it's swinging back, I try to hit it, that won't work. That won't give it more energy for each hit I throw. So I can use 3 baseballs and knock something over, and there's always a trick to it. You got to throw them at the right time. You throw them at the wrong time, it doesn't work. All right, and the same idea is happening with these electrons. The idea is that you have to increase their energy, and you can by the frequency. So it's sort of telling you that this is not a photon. A photon is a frequency. It's not, you don't have a radio wave and have a blob that's a mile long or 10 miles long. So it's not a blob. It's an event, and the event is the frequency. So you can sort of understand that it's light quanta would, in Einstein's words, wouldn't mean this. It would mean this, bits, at a frequency, a period between their arrival at a location. And that makes it kind of obvious that, well, if I have a high frequency, it means the electron, let's say I'm hitting an electron, and I was going to move it, and we knew it slowed down as it went. So the sooner I hit it the second time, right? If I hit it once, okay, and it slows down before I hit it again, I can't make it go faster. I can just make it go, say, 30 miles an hour, That's, I make it go 30 miles an hour by hitting it once, then it loses the 30 miles an hour, goes back to 0. And I can give it 30 miles an hour again, but it goes back to 0. And then 30 miles an hour, it goes back to 0. So the electron won't go anywhere because it can't get enough velocity to leave. See, it needs 50 miles an hour to leave. But if I hit it when it's still going 10 miles an hour, then I hit it again, then it's 30 plus 10, right? And if I hit it again, okay, when it's going 40, then it's still going 30, or still going 20, let's say, and I hit it again, well, then 30 plus 20 is 50, and now it's got enough velocity to leave. And obviously the higher the frequency, that is, the narrower this gap between events, the faster the electron's going to be going, and the faster it's going to leave. And so it perfectly explains the photoelectric effect. It perfectly explains how increasing the frequency increases the velocity of the electron, because you're not letting the electron slow down. And I would illustrate this as happening on a surface, because the what you're doing is you're hitting an atom with a little discrete bit, and the idea is that atom pushes on the electrons, and so you could hit anywhere. You could hit here. So the electron is pushing in all directions. The atom gets hit. It's like a puddle. It's going to push all of its electrons out, all the ones that it has, and they're going to put pressure on the other electrons in the neighboring atoms. So you're putting pressure going in all directions. And the simple truth is I could hit it again here. Here's where the second one could hit. And it's hitting while this electron now in this other atom is moving. So this is about atoms spread over quite a distance. A photon isn't a small, discrete thing. It's small and discrete relative to us. Okay, but the fact is this frequency, if you took this as a distance, it's it's let's say 700 atoms. Of average atoms. It's 700 atoms across. So this event, this polarization, that is the spread of the photon, is over a 700 atom space. So what you're really saying is I hit one atom with one bit, the other atoms are all affected, the electrons are now moving in a direction, and then I hit again. And now I give that electron twice the velocity. And you can get it that, and I hit it again, then I give it 4 times the velocity. And now it has the velocity to leave. And the higher the frequency, the faster this leaving velocity is going to be. All right, so it's a perfectly good illustration. Now, I would argue the polarization is just means that you're going to, when the atoms are going to hit, it's like, the old days when they, had fighter airplanes and they'd come down and scrape a surface with their bullets. The idea is that the photon isn't going to hit just one spot. It doesn't hit one spot. All right. The idea is the photon is these little bits, and they're running in parallel with each other. So their frequency is associated with a difference in distance between them. So they have this frequency, okay, and they have this polarization. All right. And so that's what needs to be understood, is that there's a separation between them, okay, that's necessary, because the idea is the first one hits, and again, you want to create a velocity, and then you want that second one to hit and boost that velocity, and then you want the third one to hit and boost that velocity. So they have to hit in sequence. So a photon is an event that happens to an atomic surface. All right, and it's really at the surface that the event happens. And so this piece here could have come from this direction. It's just about hitting in the right sequence. It's about hitting in an order. Bang, bang, bang. And the order has to be in a line, obviously. All right, for the photon to really work, it needs to be aligned. And so that's the polarization. All right, and so you're really just saying that this distance between them in spatial dimension means that yes, now you can have the hit, push, another hit, push, and another hit, push. And that's the whole idea of creating the photon. So the bits of energy themselves all have the same momentum. They're all the same thing, little quanta of energy. So the quantization stays correct. I mean, you don't have to ruin quantization to understand this particular idea that a photon is an event made up of these discrete bits. There could be 3, 4, 5. Don't know how many is required, but regardless, it's a simple procedure to create the event. And the same thing goes for the electricity. To create electricity, you have to hit the surface and basically cause an electron to gain enough speed to do what sound sort of does. So sound has a sound barrier, okay, and you have to break the sound barrier to cause sound to propagate. You have to move something quickly to make sound happen. And the same rule exists for electricity. You have to get to a certain speed of an electron for this current, this procession of electrons. Okay, the electrons on each little atom have to basically push on each other very efficiently and move the energy in a direction that becomes your current. That becomes your bit of electricity. So whether it's ejecting or it's moving it as electricity, it has to have this sequential event take place to give it enough energy to move the electrons, move them out of their atoms, jump them from one atom to another would be a way of looking at it. Each atom has its own electron, and what you're basically doing is trying to get electrons going fast enough that they can break free of the existing atom and join another atom. And so you're really just propagating, pushing the electrons off of the atoms, and it requires a certain minimum amount of velocity to be able to force electrons to be popped out of their atoms. Alright, so that's probably enough for this video, just to give a premise that there's lots of ways it could be understood. And the fact that they're telling us what we must believe, there's only one viable theory in the whole world about how photons work, and we must believe this standard dogma of physics that maybe 15 men decided what we all have to believe, and it's just really bad science. They don't allow their theory to be tested. They don't allow it to be argued. They just preach it from their ivory towers and tell us all what we must believe. They know, they have the answer, and in my opinion, their answers are horrible. They're so silly and fabulistic. They might as well be telling me invisible men exist and gremlins exist. It's just garbage as science. Alright, so leave us read some of this tripe. A photon, blah blah blah, who cares, is an elementary particle, so that's a big mistake. The photon itself is a composite object. It's an event. Photon is an event. If you understand it that way, it's so simple. And that's what the frequency is. The frequency is the timing of the event happening. Bang, bang, bang. Or in the case of blue light, bang, bang, bang. All right. That is a quantum. So again, they have to throw the word in there. Of the electromagnetic field. So again, the field is just these little bits. All right, then the fact is they're hitting all the time, and some of them have a frequency and some of them don't. So you can just turn the field into a photon anytime you want, just because you're moving an electron in the field. And if you vibrate an electron, you're going to end up creating a photon, in the sense that you're going to create the likelihood of a photon, but you're creating a pulse in the field. You're compressing the field and then relaxing the field, and compressing the field and then relaxing the field. So the energy is reflecting off of you. And if I did this with my hand, you could see it. You could see bright, less bright, bright, less bright, bright, less bright. Come on, not that complicated. So electrons are producing the little bits that can become a photon. But one single electron can't make photons. All right. It can't give you the polarization necessary. Anyway, so you need more than one atom to be doing this. Okay, and then you'll make photons. All right, field, including electromagnetic radiation such as light and radio waves. So this is just a way too run on a sentence and convoluted. It has too many concepts in it. So obviously light has a spectrum of frequency, and there's nothing different about radio waves and visible light and gamma rays, except for the fact that you're compressing the frequency, and that is it's going to tip things over a lot easier. Okay, the machine gun, the bullets coming out of the gun very fast are more likely to knock things over than bullets coming out at a slower frequency. All right, radio waves and the force carrier for the electromagnetic force. So again, photons themselves aren't carrying the force, they are made of the force. So it's kind of wrong to call them force carriers. An electron is a force carrier. The electron gains the force, the little bits stick to it, move it faster. So the electrons are a carrier. Photons aren't carrying, they are made of, okay, the energy quanta. Photons are massless, so this is one of the silliest things physics made up. They don't have any evidence of this at all. There's no such thing as, they clearly have momentum. They can't be called massless. They have to have a mass to have momentum. It's just a nonsense. And here they say it, photons are massless. They force us to believe this. Okay, in particle physics, a massless particle is an elementary particle whose invariant mass is zero, which doesn't even say anything, invariant mass. So they're saying that something like a rest mass, like somehow you could actually have a photon that it's not moving, which is absolutely ridiculous. So this is just at present, the only confirmed massless particle is the photon. I mean, again, just too frickin' silly. They just made all this crap up and they preach it as if it's some sort of highly evidenced truth. Not even close. They have zero evidence to conclude photons are massless. Zero. So they always move at the speed of light in vacuum. So the reason why they move at the speed of light is sort of unknown to us. We can't know why they move the speed of light, but the fact is we know they always do when they're free as a force. That is, when they're flying through the universe and they're not pushing matter, they clearly move the speed of light. The argument I would make is when they are pushing an electron, they're not moving nearly as fast as the speed of light. So when they're stuck to an electron as a little motor pushing it, a little flagellum, they're not going to be going the speed of light anymore. When they are in vacuum, so again, more blah blah, they're always in vacuum, frankly. From their perspective, they're always in a vacuum. The real universe is the little universe, okay? And it has real vacuums in it. I mean, hard, 100% vacuums. The photon belongs to the class of boson particles. So there's no other bosons. There's just the idea of this quanta, and the quanta makes everything else. Different patterns in the quanta create different phenomenon. So they're basically talking about what causes electricity, which is a photon. But you can also send photons, send the elementary bits in a pattern, and that's magnetism. As with other elementary particles, photons are best explained by quantum mechanics. Says them. I mean, it's just so silly. Best explained. If you want a silly, crazy, wooey nonsense answer, sure. All right, and exhibit wave-particle duality, which they don't. So it's an absolute fact that any rational analysis of the double-slit experiment proves that photons are not waves. They are, in fact, have to be something other than a wave, because guess what? The wave diagram doesn't work. The wave math doesn't work. If the two-slit was just two sources, two waves, then the mathematical dimensions, that is the center of the wave being in the center of the slit, would give you wrong answers in predicting the fringe pattern. So it doesn't even work mathematically, and yet they assert it. Fact, gotta believe it. Their behavior featuring properties of both waves and particles. So there's barely any properties associated with a wave, okay? I mean, essentially none, because waves don't actually match. The wave math doesn't work. It's just a truth. If you put the center of the waves where the actual dimensions that work, that is the surfaces of the slit experiments, are the dimensions you must use if you want to correctly predict where the fringes are going to be, there's no reason for wave centers to be on the surfaces. Waves don't form there. Okay. The modern physical concept originated during the first 2 decades of the 20th century with the work of Albert Einstein. So again, they're crediting Einstein with having said something that he didn't say. So he didn't agree with a lot of this quantum mechanics crap and these wooicles and all of that crap. And the only thing he conceded is that, 2 years before his death, he was quoted as saying, look, I've been studying photons for 50 years and I haven't improved my understanding one iota. Clearly, Einstein wasn't as confident as this crap that's written here is. Clearly, Einstein was a little doubtful that, we have all the right answers and our little wave-particle duality is perfectly brilliant nonsense. No, he didn't think so. Who built on the research of Max Planck while Planck was trying to explain how matter and electromagnetic radiation could be in thermal equilibrium with one another. So this is always the tricky question, in the sense that it's also a gravitational question. Okay, the Earth is going to excrete the energy that comes in. The Earth doesn't get hotter and hotter and hotter as time passes. But the fact is, it's consuming energy constantly because that's the byproduct is gravity. And so that leaves you with this dilemma. But the fact is that all these black bodies have to be constantly fed motion. Something can't be moving unless there's something moving it. So it has to absorb something to move. And the fact is you have to constantly feed movement because the bits that are pushing 1 minute aren't going to be the same bits pushing the next minute. So constantly the force has to regenerate motion in electrons and protons. They are dragged to a halt and they need to be constantly fed new energy to keep moving. All right. So, that's what I'm telling you, okay? I'm telling you that's the truth. They're going to argue a different theory, but they're not going to argue it from any better facts than the facts I have. All right. The evidence isn't clearly pointing, okay? It's little pieces of evidence, and they all have to be carefully analyzed and carefully put together. Again, if they carefully analyze the double slit, they can clearly see that in the double slit experiment, there's two different sources. There's two outside surfaces very far apart that are creating the small fringes, and then there's two interior surfaces that are very close together, and they're creating the big envelope pattern. But they never did that careful analysis. All right, well, Planck was trying to explain how matter and the electromagnetic radiation could be in thermal equilibrium with one another. He proposed that the energy stored within a material object should be regarded as composed of an integer number of discrete equal-sized parts. So this is where you get to again, it fits, okay, this idea of the elements of a photon being quanta. Okay, and it's just at a frequency. So you put this elemental energy at a frequency and it all starts to fit. So this photoelectric effect is basically my tipping point argument. It's just pointing out that you need this certain minimum amount of event or there's no photon. And so if you do things too slowly, the system relaxes and you can't add energy to it. You do it quickly enough, you can add energy. And it's that simple. All right. To explain the photoelectric effect, Einstein introduced the idea of light itself being made of discrete units of energy. So that sentence, all right, you read Einstein, it's hard to say what the hell he's saying sometimes. Okay, frankly, he was kind of brief in how he described anything, and he didn't draw pictures of it. But this sentence is exactly what I just described to you, right? Einstein introduced the idea that light itself, okay, a photon, is made of discrete units of energy. So the photon itself is not one thing, it's an event, it's numerous things happening. All right, in 1926, Gilbert and Lewis popularized the term photon for these energy units. So who cares about when they decide to call it a photon? Subsequently, many other experimenters validated Einstein's approach. So this is all the confirmation bias and whatever, but it all requires that they have some interpretation. Again, they have to interpret the data, and they have to interpret the explanation for the data and say, okay, do we believe it or do we not believe it? And again, they're just doing it because they don't have choices. There isn't a bunch of evidence. They're required to say, okay, which one do I think is more possible? And so it's very thin evidence that all of this is based on. Again, 2 years before his death, Einstein said, I've spent my whole life studying photons, and I haven't improved my understanding one iota. Okay, I have no more complete understanding of a photon. So a huge concession, a reasonable humility, stating that he's still very unsatisfied with what science says a photon is. In the Standard Model, so the Standard Model is just such convoluted crap. It's a mathematical pile of crud as a model. They can't draw it, can't illustrate any event that takes place in the universe with the Standard Model. It won't work. Photons and other elementary particles are described as necessary consequences of the physical laws having certain symmetry. So again, the symmetry is obvious to everybody, okay? The system cause and effect is all that's really saying. And, so we don't need modern physics to figure out their symmetry. The whole reason why planets and the sun are spherical is because of this symmetry and pressure. All right, well, anyway. At every point in space-time. So to bring up space-time is just to ruin a perfectly good mechanical subject. Now they're just going to ruin it, okay? So Einstein fixes it a little bit, and then he totally ruins all of physics because every freaking subject has to be soiled with the poo of space-time. The intrinsic properties of particles such as charge. So again, let's say, this is another lie, okay? It's not an intrinsic property of particles, okay? It's a charge is a specific of only two particles, electrons and protons. There's nothing else that we know has anything called charge. And so they just made up these fake properties. So we know things have mass, okay, because they have momentum. Charge is electrons and protons. There's nothing else obviously charged. And spin is just a total waste of time. There's no such thing. And they don't even think of spin as actual spin. It's some other orientation that they think an electron can have an orientation. Are determined by gauge symmetry. So this is another pile of absolute nonsense physics. Just simple, way oversimplification, doesn't mean anything. So it says gauge theory is a type of field theory in which the Lagrangian and hence the dynamics of the system itself do not change under local transformations according to certain smooth families of operations. I mean, what is that mush? And this is what they force. They say we have to believe in this gauge theory, and we have to believe in these, Lagrangians. No, we don't. The photon concept has led to momentous advances. So this is just such a lie, okay, that somehow the concept of the photon led to any advances. Absolute nonsense. The basic idea that the photon is energy led to advances. Nothing else did, okay? It was all hard work to get anywhere. So again, the photon theory did not invent lasers. That's just nonsense, okay? Lasers were invented by the idea that we could make sources of light more and more discrete, okay, and more electronic, and that made it possible to create environments that could laze. All right, but all the rest of this stuff is meaningless. Bose-Einstein condensation, you're not going to buy one of those at the store. Your car ain't going to run on one. Quantum field theory, well, guess what? That ain't going to make a car run either. The probabilistic interpretation of quantum mechanics, that didn't invent a single thing ever. So it's all just such hype. They make this argument somehow their silly gauge theory or some other nonsense actually advanced physics in some way, and it's just a lie. It has been applied to photochemistry, high-resolution microscopy, and measurements of the molecular distances. So all bullshit, okay? They haven't even measured the electron's mass correctly because they're using the silly 1/2 mv² formula to do it. Moreover, photons have been studied as elements of quantum computers. So we know, well, come on, all this hype about this quantum computer crap. It hasn't never done it. Computed a damn thing. All it can make is errors. Okay, so if you want to make a mistake really quick with a computer, this is the fastest, most broken computer in the universe. It's a quantum computer. You want to get an irrational answer to a question, ask a quantum computer, because that's all it's good at. Getting the wrong answer insanely fast. Okay, and for applications in optical imaging and optical communications, such as quantum cryptography, okay, all bullshit that hasn't accomplished anything, hasn't added to your technology at all, doesn't make your cell phone work better. None of this crap has anything to do with actual advancements in technology. It's all crappy theory. It's all mushy gremlins. Believing in gremlins will not make you a great inventor. All right, and believing the nonsense they believe will not enhance your capacity to invent anything. All right, so here they have a diagram of the photoelectric effect. Can you see that? Yes, you can. Okay, and it's just drawn wrong, right? Because, okay, the photon doesn't come in, pop an electron right out. It's not that simple. The frequency has to be applied. It has to go bang, bang, bang. It has to hit behind the energy and hit behind the energy and hit behind the energy to force the energy to have more energy, right? I mean, it's that simple. You have to add energy to a system of atoms, not a single atom. So this is, but the idea is the same, right? The idea is a tipping point argument. You're saying you need a certain amount of energy to get an electron out. Well, why do you need a certain amount of energy? Well, you need a certain amount of energy, frequency, because of this fact that electrons stabilize. They move and then they stabilize. They go back to where they were. So if you want to kick them out, you have to hit them twice or 3 times to kick them out. You can't just hit them once. And if you hit them too slowly, you're not going to kick them out. If you hit them fast, you'll kick them out. That simple argument is the only thing that's really been proven. And clearly, a simpler theory of what a photon is explains it perfectly. All right, the word quanta, okay, was much used before 1900 to mean particles or amounts of different quantities, including electricity. So yeah, it's a perfectly good word, and they've ruined it, okay, because they don't even think these particles are actually particles. So the funny part is that they're taking the whole idea of the universe being made of these standard parts, quanta of charge, an electron, quanta of charge, a proton, quanta of energy, the forces moving the speed of light. They've ruined that simple model, okay, and that simple idea. They just ruined the word quanta, the idea that the universe is made out of quanta of cause and effect. There are events, little subtle events that are taking place in the universe, and those subtle events create the more complex emergent events. All right. In the 1900s, the German physicist Max Planck was studying black body radiation, and he, what do they call this? Nomenclature. Oh, this is the nomenclature section. And he suggested that the experimental observations, specifically at shorter wavelengths, would be explained if the energy stored within a molecule was a discrete quantity composed of an integer number of finite equal parts. And obviously the atoms are composed of that, especially in a metal. All the electrons have the same pressure. That's why electricity moves, is because the pressure is moving. So you can't change the pressure of one atom without changing the pressure of all the atoms, the electron pressure, how much motion or jiggle there is in an electron. It dampens into the whole thing because all the atoms are connected to each other. And so the idea is that the quantum for the atom is the pressure of the electron. So every atomic structure, every material, has a different pressure. It has a different amount of pressure of its electrons. And that's why you get different colors, blah, 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 blah. It's because of that difference in pressure. But the idea is you're moving the electron, and that's the quantum. And that's the thing. For every material, there's a different number, there's a different place at which it will start to eject electrons. So you need a different amount of speed for a different metal, a different kind of material. So some silicons will actually eject electrons at, with red light. Some materials will, and then other materials require you to hit it with gamma rays before you can eject electrons. So it depends on how tightly bound the electrons are in the atoms. So a perfectly valid observation, okay, that it seems like atoms require a certain chunks of energy. That is, you have to be able to, a chunk of energy moves an electron. An electron is a clump, and you need a clump of energy to move an electron. All right, the idea that the energy needs to come in clumps is a perfectly valid way of understanding it. All right, specifically shorter wavelengths would explain if the energy stored within a molecule was a discrete quantity composed of integer numbers of finite equal parts. So the finite equal parts are the pressure of the electrons, which he called energy elements. In 1905, Albert Einstein published a paper in which he proposed that many light-related phenomena, such as black-body radiation and the photoelectric effect, would be better explained by modeling electromagnetic waves as consisting of spatially localized, discrete wave packets. So I don't remember that Einstein used the word wave packet, frankly. I remember him using the words light quanta. He called such a wave packet a light quantum. There you go. So he didn't use the word wave packet. He said light quantum. Okay. So he's basically saying these little discrete bits that make up the photon. All right. The name photon derives from the Greek word for light. So again, the word photon gives us the wrong impression, because the word photon makes us think of electron or proton. It makes us think of a single object. And it's not a single object. It's a composite object made of events that happen at a frequency, a migration of hits. It's bang, bang, bang is a photon. A photon is an event. Okay. The name photon derives from the Greek word light. Who cares? Again. Okay. Arthur Compton used photon in 1928, referring to Gilbert A. Lewis, who coined the term in a letter to Nature. So it really was late in the game that they used the word photon. So in Einstein's paper, he obviously didn't use the word photon. He said light quanta. The same name was used earlier, but was never widely adopted before Lewis. In 1916, by the American physicist and psychologist Toland. Okay, apparently he was a nut. In 1921, the Irish physicist John Joly. In 1920, who cares? I mean, all this stuff over when they decided photon was a cool word. Anyway, the name was suggested initially as a unit related to the illumination of the eye and the resulting sensation of light, and was later in a psychological context. So again, I mean, who cares about all this, where the word comes from. In physics, a photon is usually denoted by the symbol funky Y thing, Greek letter gamma, and this symbol for the photon probably derives from gamma rays, which were discovered in 1900, named by Ernest Rutherford in 1903, and shown in the form of electromagnetic radiation in 1914 by Rutherford. So we're just talking about the frequency thing. So obviously that came in chunks of, Faraday basically. Was it Faraday? Somebody, obviously gave you this reason to start believing that there could be other wavelengths of light. I mean, even Newton discovered that, right? I mean, Newton discovered that there was something happening in the infrared, that there was an event. So there was some indication that there was light there, okay, but we couldn't see it. It was of no color. The photon has no electric charge, so, I mean, duh. I mean, really, the idea that they have migrated charge to anything other than electron and proton is bizarre to me, frankly. I mean, I just don't even understand how they could think charge could exist in any other form but an electron and a proton. It is generally considered to have zero rest mass. So again, generally considered, they say now. So before it was an emphatic statement, now it's generally considered to have zero mass. And generally considered for what reasoning? What evidence just points out that photons have to be a massless particle, except some mathematical reason to make them massless? No, there's no logical reason to do it. And is a stable particle. Well, that's pretty dull. Duh. The experimental upper limit on the photon's mass, so this is again very silly, is very small and on the order of 10 to the minus 50 kilograms. So this is all their stuff they're making up about how much energy it has. And see, they think the energy is dependent on the frequency, but that just has to do incidental. So I have 3 baseballs. If I make the baseballs hit the surface, bang, 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 it'll tip it over. And that'll look like a lot of energy. And if I throw the same baseballs at the same speed, but I throw them bang, 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 it won't tip anything over. Now, it's the same energy. Okay, the same energy goes into the stick. It's just that the energy is in a form that the stick can't be knocked over by. So it's just so wrong that they think you can change the energy of the quanta. You can't. And you can't even change the energy of the photons. But what you're doing is having an incidental effect. That is, it has an effect if the energy is in one form, and it won't have the same effect if it's in another form. So I could do that by just poking something with my finger, and I can apply the force over a long period of time and make no hole. Or I could poke my finger in very quickly and make a hole in it. So it's the same amount of total energy. It's just that you've changed over how much time you're applying the energy, which makes a difference to material surfaces. I mean, they've made such a mess out of something so simple. All right, its lifetime would be more than 10 to the minus 18 years. So they're talking about the lifetime of a photon. It's just so ridiculous. The energy in the universe is forever, okay? And photons are the energy in the universe. They're part of that spectrum. They're part of what makes gravity and magnetism and all the stuff moving the speed of force. All that stuff is eternal. It never dies. It just changes who it's interacting with. For comparison, the age of the universe is about 3 times 10 to... I mean, you know, like they know any of this crap. It's just, oh, it's so disgusting that they, they talk this shit. Oh, all right, well, let's finish this paragraph. In a vacuum, the photon has 2 possible polarization states. So this is... They're not going to tell you what the facts are about polarization. That is that... the fact is that in all electromagnetic radiation, that is, antennas kind of demonstrate that the polarization has a relationship to the frequency. So the smaller the frequency, the smaller the polarization. That is the spread. So you're talking about the bits, you know, being in space, parallel to each other, but that they're in different places. So they have a distance between them this way, and they have a distance between each other this way. All right, that's the polarization, and it always tends towards being very proportional to the frequency, and it's a real amount of distance. So if the frequency is 1,000 atoms thick, then you know the polarization is probably 1,000 atoms thick. Photon, we did that. Okay, in a vacuum, photons have 2 possible polarization states. So the polarization just means how the bang, bang, bang event happens on a surface. And if it's linear, it's a photon. If it's not linear, it won't be a photon. The photon is a gauge boson for electromagnetism, so it says U. And therefore, all other quantum numbers of the photon, geez, it's just quantum numbers, such as, oh, here we go, lepton number, baryon number, and flavor quantum numbers are 0. Oh, it's just such silly talk. I mean, this is, they might as well just say the gremlin number, the pixie number, the hooly booly number. It's just all just made up nonsense. Also, the photon obeys Bose-Einstein statistics and not Fermi-Dirac statistics. Oh, gee, I'm so terribly upset that it doesn't fit Fermi-Dirac statistics. Anyway, just too silly. That is, they do not obey the Pauli exclusion principle, so somehow photons can be in two places, and they can have the same numbers, and they can have the same hairstyle, and there's no law against it. They can have exactly the same hairstyle, and there's no law against it. They can both be wearing blue t-shirts, and there's no law against it. I mean, this stuff is so fucking silly. They needed some physicist to tell them that two things can't occupy the same space. They actually need a physicist to tell people that two objects can't be in the same exact space at the same exact time. Oh, duh. What a surprise. And more than one can occupy the same bound quantum state. Just so sickening. They talk this. It's just terrible. This is like baby talk. It really is like somebody telling some silly little fairy story about the purple pumpkin man and the little green blue Smurfy people. There's just creepy. Photons are emitted in many natural processes. For example, when a change in acceleration, it emits cyclotron radiation. Oh, brother. So cyclotrons are full of ions. Okay, so they just have an ion gun, so they're shooting electrons and partial atom nuclei, and it's a big surprise that some photons pop out. Now, not a surprise at all. During a molecular, atomic, or nuclear transition to a lower energy level, so again, they don't really even understand energy levels in atoms because they don't even get that the high pressure is on the inside and the low pressure is on the outside. Photons of various energies will be emitted, ranging from radio waves to gamma rays. So this just has to do, again, with what electrons you're disturbing in what pressure. So if you're reducing the pressure of an electron, you're going to get a low frequency photon. If you're increasing the pressure, you're going to get a high frequency proton. So if you're pushing on an atom and you're making the electrons closer to each other, they vibrate quicker. If you're relaxing the atom, then they vibrate slower. That simple explanation covers the subject. Photons can also be emitted when a particle and its corresponding antiparticle. So we have to believe in antiparticles. They've told us it's the truth. It's undeniable. We have to believe. Bullshit. Are annihilated, for example, electron-proton annihilation. So, no, just nonsense. All right, so we'll call that a video, and then later it actually gets to, I think, Newton and, here's Huygens. I mean, a Young experiment, and then some talk about Huygens and Newton disagreeing. So there's some of this might be worth getting to. I mean, all this rubbish where they're going to tell us we have to believe in all of this Fermi crap, lepton crap, baryon crap, flavor crap. I know gauge boson crap. It's all crap. And they tell us we have to believe. You can't argue it. You can't debate it. You can't say, show me. You can't do any of that. They're just going to tell everybody has to believe in their silly fucking funny hat theory. I just hate this planet. Why you dupes want a world like that where nobody's tested. You don't test anything. You don't seek the truth. You just accept a stupid song they're singing and you start singing it. It doesn't matter what the song says. I have a big fat nose full of stupid, ugly, smelly boogers. And you'll sing that song because somebody else is singing it. You're just so fucking stupid. You insult your own intelligence. You obnoxious morons. I mean, all the, hundreds of billions of neurons, and you're wasting them reciting silly fables. Ugh. Shit. So, fuck Wikipedia. In the appropriate location till appropriately ceasing to be the shithole that it is. Anyway, till the next time and such. God, it's so depressing.